One more set of practice using spherical coordinates. Let's describe sets of points, regions in three-dimensional space in spherical coordinates. So take a look here. Describe the region x squared plus y squared plus z squared is less than or equal to 4 in spherical coordinates. Well, rho here, rho is going to equal that marker went flying. I'll get it after this video. I got a backup orange pen here. Rho squared is equal to x squared plus y squared plus z squared. And so what is this? Rho squared is less than or equal to 4. So we have rho is less than or equal to 2. Also, we should know from our natural bounds, we never let rho get negative here. So this region is going to be, rho is between 0 and 2. If we draw the picture, this is just a sphere of radius 2. So sphere of radius 2, everything inside a sphere of radius 2, that's this set here. X squared plus y squared plus z squared is less than or equal to 4. Okay, this is maybe a warm-up here. The next couple are going to be a little bit more interesting. So let's describe the region x squared plus y squared plus z squared is less than or equal to 4. Z is negative and y is positive. Okay. And really, to do this, I should point out, I didn't write down, and probably I should have, written down the bounds on theta and phi. If I don't write down the bounds, I'm probably just assuming that I'm using the natural bounds here, which is theta is everything from 0 to 2 pi. We go one complete trip around the circle in the xy plane, so that's 0 to 2 pi. Phi is 0 to pi. Because now in this one, we are going to care about bounds on rho and theta and phi. Okay, so let's do this. This is still giving us x squared plus y squared plus z squared is less than or equal to 4. That is still giving us rho is between 0 and 2. Now, how about the z being negative? So this picture right here, this was a sphere of radius 2 centered at the origin. We want, once we slap on z is less than or equal to 0, that's going to make it so that we're in the bottom hemisphere. So the first picture I'm going to draw here is this bottom hemisphere. What corresponds to z being less than or equal to 0? This is going to be, we know in the xy plane, that's corresponding to phi is pi over 2. So we're making the angle front with a positive z-axis, 0, pi over 2, pi. So this is going to be, phi is running from pi over 2 to pi. That's the picture way to get the phi bounds. Let me also point out here that if we go back to this right here, z is rho cosine phi. Well, z being less than or equal to 0, we can also get the same result by saying that rho cosine phi is less than or equal to 0. And we're assuming phi, phi isn't going to be negative. We decide out by rho to just get cosine phi being negative. What values of phi make cosine of phi less than or equal to 0? Exactly phi between pi over 2 and pi. You could also say, oh, but it's also true for pi to 3 pi over 2. But once again, let me remind you, for phi, we never go outside the interval from 0 to pi. Okay, so phi runs from pi over 2 to pi. How about y here? Y being negative, or sorry, y being positive, x, y, z. What region here is y being positive? So it's not the entire hemisphere, it's a quarter of the sphere with y being positive. So in the xy plane, let's draw in the xy plane. In the xy plane, we're on this side of things, and we should realize here that y being positive is corresponding to, this is going to be corresponding to theta is running from 0 to pi. So that gives us that. I guess you could also get here that y is rho sine theta sine phi. So y being positive is rho sine theta sine phi being positive. Rho is never going to be negative, so we divide out by rho without changing the direction inequality. Sine phi, for all values of phi between 0 and pi, sine phi is never negative, so we can divide out by that. So sine theta is non-negative. When is that? When theta is between 0 and pi. Okay, let's slap on one more twist here. Describe the region x squared plus y squared plus z squared is less than or equal to 4. So again, we're starting off with a sphere of radius 2, center at the origin. Z is greater than or equal to 1, x is greater than or equal to y. Okay, so what do we know here? This is, again, going to be rho squared is less than or equal to 4, or rho is less than or equal to 2. Okay, what else is going on here? So, to draw our sphere of radius 2 here, but now the interesting thing here is that we're slicing it when z is equal to 1. And so we're kind of taking the top, like a little hat here, a little spherical cap, when z is equal to 1, so z runs from 1 to 2. It also will have x is greater than or equal to y. So there's going to be a lot going on here. So let's take this just a little bit at a time. If we take a cross section, if we kind of look at this, in this direction, looking straight on from the positive x-axis, the picture in the YZ plane is going to look like this. Okay, so what are going to be the phi bounds here? What are going to be the phi bounds here? And by the way, I need to come back to the x is greater than or equal to y. We'll worry about that in a little bit. So this picture might be a little bit of a lie, but let's get the z is greater than or equal to 1 stuff down first. So what are the phi bounds? So something, it looks like phi is going to run like from here to here. So what phi corresponds to that angle right there? So this point right here, this is going to be it. So we're on the circle x squared plus y squared plus z squared. Sorry, the sphere x squared plus y squared plus z squared is equal to 4. I said we're kind of, we're doing the cross section here with x is equal to 0. So y squared plus z squared is equal to 4 here. So if z is equal to 1, here, then that would make y equal to square root 3. So we have that point there. So then what angle would give us square root 3 comma 1 here? What angle would do that? This would be pi over 3. Phi is pi over 3. If you're unsure, if you're unsure, like we can just look at the picture to kind of see that. But maybe it's also useful to bring back this formula right here, cosine phi is 0 over rho. At this point right here, z is 1 and rho is 2. So cosine of phi is z over rho is 1 over 2. And so this gives us phi is pi over 3. So the phi bounds are going to go from 0 to pi over 3. Now you might be asking me at this point, you know, like this feels like what we did in the polar coordinate section. You're saying, well, what about over here? But this angle is still going to be 0 to pi over 3 from the positive z-axis. How do we get over here? By choosing different values of theta, which we haven't discussed yet. So the phi bounds are going to be 0 to pi over 3. Also in this picture, let's go ahead and figure out what rho bounds are going to be. Because the rho bounds, we have to be careful here. Now, certainly rho can never be bigger than 2. We have that from up here. But now the rho bound, this lower rho bound here, is going to depend on phi. So rho, sorry, phi, I want to say rho here. Rho at like this angle will be those, you know, that bit of rho. But rho at this angle will be that bit of, you know, like the rho choices here are different. And here's where this is going to feel like we did back in the polar coordinate section. We need to convert the line z is equal to 1 using this formula right here. So z is equal to 1, but that tells us that rho cosine phi is equal to 1. And so that lower bound right there, divide by cosine phi, is rho is equal to 1 over cosine phi, or rho is equal to secant phi right there. And that gives us our lower bound. So it should feel similar to what we did in the polar coordinate section. Okay, so we have our bounds on phi, we have our bounds on rho. To finish this off, okay, x is less than or equal to y. Let's draw the picture here in the xy plane. So x is greater than or equal to y. I may have misspoken a few seconds ago. So there, that's a mostly dead marker. Here's the line, x is equal to y. We want to be on this side of things, but inside of this circle here. So this looks like our theta bounds are running from, let's see, pi over 4, and there's a negative 3 pi over 4. And so those should be our theta bounds. So take that, copy paste that over here. This might look like I'm kind of messing with the natural bounds here because I'm using theta from, I'm using negative values of theta. It is okay as long, to go outside of the 0 to 2 pi range like we do here, but we should never, ever, ever go phi outside of 0 to pi. Okay, so I know this is a pretty long video at this point, but being able to describe these regions is really, really important for when we go to doing integration in spherical coordinates.